So we are going to see about the avoidance algorithm. In the previous video, we saw about what is deadlock avoidance algorithm, and we saw the condition for this deadlock avoidance, that is mutual exclusion, hold and wait, circular wait, and no preemption. This avoidance algorithm can be happen in two ways. One is for single instance of a resource type, and second is multiple instance of a resource type. Use a resource allocation graph if it is a single allocation, single instance of a resource type, and if it is a multiple instance of a sequence type or a resource type, we are going to use the Banker's algorithm here. So the algorithm is explanation is followed here. Like we have a edge called as claim edge, where a process is requesting a resources, which indicates uh, in a dashed line we can mention it if a process is requesting for a resource. Claim edge, which will convert to request edge when a process requests a resource. Request edge converted to an assignment edge when the resource is allocated to the process, and when a resource is released by a process, assignment edge reconverts to a claim edge. So here the reverse process will be taken place. And this is the resource allocation graph here. The dashed line is called as the resource edge. R1 is holding P1 and P2 is requesting for R1. Unsafe state in resource allocation. See, this is unsafe. So now we are going to see about the Banker's algorithm. Banker's algorithm, which will work for multiple instances. Each process must a priori claim maximum use. When a process requests a resource, it may have to wait. When it gets all the resources, it must return them in a finite amount of time. So this way the Banker's algorithm will work. Please ensure that if it is a Banker's algorithm, we are going to use it for multiple instances. If it is resource allocation graph, we are going to use it for single instances. What is actually the structure or the data structure what we are going to follow for Banker's algorithm? So assume that we have a number of processes as n and m as number of resources types. We need for four things. One is available, max, allocation, and need. What is available? What are all the resources available, which is mentioned in the available data, and maximum. How much maximum resources a particular process need, that is kept in maximum, and how much it allocated, that will be kept in allocation, and what is the proper need of a resource, that count will be kept in the need. So the formula for need is we can find from maximum minus allocation. What is the safety algorithm? Let work and finish be the two vectors of length m and n respectively. Work is equal to available and finish is equal to, it depends. It may start from 0 and end with n minus 1. The need should be less than or equal to work. So work is equal to work plus allocation. So see here. Example, we will see totally we have 5 process P through and 3 resources type. Total instance they have given as 10 and 5 instances are there, and C is equal to 7 instances. Here this is actually the snapshot for a particular problem. You have 5 process, say P1, P2, P0, P1, P2, P3 and P4, and we have allocated allocation as for A, B, C. We have 010 200 302 211 002. And we need to find the need. Need is equal to maximum minus allocation. So here the content, how we can find the need, that they have given here. If the request is less than or equal to available, if the condition is satisfied, then we can check whether this process can enter the safe state or not. We have to check the allocation. The allocation is 102, which is less than or equal to the available is 332. Yes, it's correct. So this process P naught can enter into the safe state. So likewise, we need to check for each and every individual processes. So the next deadlock reduction, we can see it in the next video. Thank you.